All right, this video is going to go over 6 trig functions. So the first thing that I would say is if you don't know this right here, which is essentially, if I don't know, back in the day they told us it was Sohcahtoa. Sohcahtoa. That's how I remembered it. So like the first one, sine is the opposite over the hypotenuse, which will be the y over the r. The cosine is adjacent over hypotenuse, which will be the x over the r. And then the tan is opposite over adjacent, which will be the y over the x. That's how I always remembered it. But if you don't know what's circled in red right there, you're not going to be very good at this. So just keep that in mind. All right, the next thing that I would say is you need to know that when I draw my triangles, this is going to deal with a lot of triangles. When I draw my triangles, I do them as a bow tie, like this. See how it makes like what looks like a bow tie? Some people draw their triangles like this, and it gets kind of confusing. So I always draw mine as if it was a bow tie. Next, you will need to know Pythagorean Theorem. A squared plus b squared equals c squared, because you're going to have to solve for the r value, the distance, kind of like your hypotenuse of these triangles. And then whenever you do solve for r, sorry about that, whenever you do solve for r, it's always going to be a positive value. So let's look at some of these. The first thing you're going to do is plot this point as if it was a coordinate. So like -3, -2 would be like here. So you're going to make a triangle out of this. Remember, I stick with like my bow tie triangle. The x value is -3. The y value is -2. Now you have to go get this r value right here by running Pythagorean theorem. So you go like -2 squared plus -3 squared equals r squared. So this makes 4 plus 9 equals r squared. So 13 equals r squared, then square root it. R equals root 13. You have to be able to find that r value. Once you've found the r value, it's pretty simple. You just plug it into x, y, and r and get your values. So cosine theta is x over r. So that's x over r. So that's -3 over root 13. Okay, one more thing. If you get roots on bottom, it's good practice to kind of cancel it out. And how you do this is you times by root 13, whatever that root is, over whatever that root is. This is 1 right here, so I'm not actually changing the value of anything. The bottom, the roots cancel, so it's just over 13. The top, it just becomes -3 root 13. This is best practice. That's how most teachers want you to do it. For now, I don't care. You can just leave the root on the bottom. So let's continue answering these. Sine theta is y over r, so that's -2 over root 13. Then tan, when I think of tan, I think of it almost like slope, so rise over run, so y over x. So that's -2 over -3, which becomes positive 2/3. And then to get these, you just flip this fraction. So like secant, I'm just going to flip cosine. So now it's going to be root 13 over -3. And also best practice, it's best practice to put your negative on top of the fraction regardless of which number had the negative sign. So yes, I know it was root 13 over -3. This is the same thing, negative root 13 over 3. Same thing. It's best practice to put that negative onto the top. All right, cosecant, I'm just going to flip sign. So that's negative root 13 over 2. And then cotangent, just flip tangent. That's 3/2. Let's move on. This next one, plot this coordinate as if it was a normal xy point. So 5, 4 would be like here. Make your bow tie triangle out of it. So my x was 5, my y was 4. I have to run Pythagorean theorem to get that r value. So it's like 4 squared plus 5 squared equals r squared. So that's 16 plus 25 equals r squared. That's 41. And then root it. So root 41 is my r. So this hypotenuse here is root 41. Now I just answer using these up here again. So cosine being x over r would be 5 over root 41. Sine y over r, that's 4 over root 41. And then tan is y over x, so that's 4 over 5. And then to get these, you just flip it. So secant, just flip cosine, that's root 41 over 5. Cosecant, just flip sine, so that's root 41 over 4. Cotangent, just flip tangent, that's 5/4. All right, and then this last one's weird. All right, so here we go. Plot this coordinate as normal. It would be like here. That means this value, this x value is -5. My y value is 0. My r value, look, r is a distance. R is a distance from the center. So this distance right here is 5. Remember, r is always positive. So r is positive 5 there. Now you're going to plug these numbers into this right here. So cosine would be x over r, which would be -5 over 5, which reduces to be -1. Sine is y over r, which is 0 over 5, which is 0. Tan is y over x, which is 0 over -5, which is 0. Notice how, even though I knew it was going to be 0, I still wrote this fraction. You'll see why in a second. Secant, flip cosine. So now it becomes 5 over -5, which is still -1. Now here's why I wrote that fraction like this, because you're going to have to flip these. So it's going to be like 5 over 0, which is undefined. Undefined. If I hadn't wrote that, I see a lot of students just write 0 here, and then they just assume that cosecant's going to be 0 as well. It's not. It's undefined. Same thing with tan, because if you flip tan, now you got -5 over 0, which is undefined. You cannot divide by 0. So these are a little trickier, but just remember your r value is always positive, and then write out each fraction on those, even if you know it's going to be 0, because when you go to flip it to get these answers, it's a common mistake to just assume 0. All right, that's how you do the 6 trig functions. Draw those bow ties. Hope this video helped.